all you're really doing is just, well, the vernacular way of saying it is keep the base and add the exponents. All right, so I'll write that at the bottom there, under the rule. Keep the base and add exponents. All right, so when you're talking about something like 5 to the 4th, so number 2, 5 to the 4th times 5 to the 2nd, instead of writing it out as 5 times 5 times 5 times, and so on, 6 times, you could just write 5 to the 6th power. Which would really be the same as saying 5 to the 4 plus 2 power. All right, so we're not going to write it out. I mean, I don't know why that's a thing. Yeah, you would. I'm not going to make you write it as 5 times 5 times 5 is 6 times. You know, like just the 4 plus 2. It's just telling me repeatedly that the Wi-Fi is either on or off. I don't need it right now, so it's kind of aggravating. But in the case of variables, which is where things get a little iffy, because you might look at this and say, well, I could figure out 5 to the 6th, 5 to the 4th, 5 to the 2nd, whatever. I can do all that in my calculator. But when it comes to variables, you can't. So the way we handle that is to think of that y as a y to the 1st power and represent it as y to the 3 plus 1, which ultimately ends up being y to the 4th. All right. So number 4, you have a little bit of a twist on it. And that really, it's not a complicated twist. It just has more to do with the fact that there are coefficients. Those coefficients of 2 and 3 have to be accounted for. But you'd take care of that separately. So you would say, okay, 2 times 3 is 6. Bless you. All right. So what we're going to focus on is just the variable components. Because multiplication is commutative, you could do it in any order that you want. So I'm going to say, well, I've already counted for the 2 and the 3 multiplied together, so let's do the a squared times the a to the 7th. So a to the 2 plus 7 is going to be a to the 9th. All right. In the case of number 6, 2 to the 3rd to the 4th, you can see how that's expanded out as 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. But once you do that, you're still using the same property of keeping the base and adding the exponents. All right, so those powers of 3 then get added to one another to give you a 12. But the shortcut to that would be, all right, well, I don't want to have to write that out every time. Let me just take the powers and multiply them together. Because what would happen here, I will do the expanded form for this one. This is the same as saying x to the 4th times x to the 4th, because when you square something, you multiply it by itself, which would be in turn x to the 4 plus 4, which results in x to the 8th. X to the 8th, geez Louise. One of those days. All right. So you get the idea that there's a general rule that, so just jumping right down to the bottom, we're really just saying that we're multiplying the powers. All right. So x to the 2nd, y to the 3rd, you have 2 components there. Those 2 components each need to be raised to that power. So first I'm going to rewrite it as x squared y to the 1st to make it obvious that each part has an exponent. And so what that means, I'm not going to write it as x squared y to the first times x squared y to the first times x squared y to the first. I'm just going to jump right to the process of multiplying those exponents, which would be the same as saying x to the 2 times 3, and then y to the 1 times 3. All right, because now that we know that all we're doing is multiplying exponents, I'm just going to multiply each one of those exponents by 3. All right, so x to the 6th, y to the 3rd. Now, this might be surprising, but the one thing that people tend to screw up on really has nothing to do with the variables, but it has everything to do with the numbers. All right, so when I have a coefficient of 2, for example, for whatever reason, people will blow that. They'll screw that part up, but they'll get the variable parts correct. So I'm going to rewrite that one as 2 to the 1st, x to the 3rd, whole thing to the 5th. All right. So we're going to treat the number the same way we would the variable, just like we did in that first example, or just like the first example showed us. So it would be 2 to the 1 times 5. Come on. There it is. X to the 3 times 5. All right. So 2 to the 1 times 5 is really the same as saying 2 to the 5th, which is what? Speak. 2 to the 5th. 32. Yeah, when you're raising 2 to powers, you're just doubling 2 as many times as the power. So 2 is 2 to the 1st, 4, 8, 16, 32, and just keep going from there. All right, so if I said 2 to the 7th power, what I would do is I would just start off with the highest power of 2 that I know and just double a couple of times from there. So the highest power of 2 that I know, quote unquote know, now would be 32. So if I needed to do 2 to the 7th, I would just double it twice more. All right, so 128. All right, so a little mental math trick. So then x to the 15th would be the other part of it. And that would be your final answer there. Now, with the negative one, you just got to be careful with parentheses because it's being raised to a negative power. So the final answer is going to be it's being raised to an odd power. So the final answer is going to be negative. And that's great because if you're going to screw up something related to a negative base, it's probably going to be when it's to an even power because people tend to forget parentheses. But this would be a case where you're probably not going to screw it up. All right, but this is the same as saying negative 2 to the 1st power. So that negative 2 in parentheses to the 1st. Multiplied by 3 because of the outside power. Then a to the 3 times 3. Then b to the 4 times 3. So then negative 2 to the 3rd power would be what? Negative 8. Then a to the 9th, b to the 12th. Sometimes people just have troubles with powers of 3 for some reason, because instead of, not because they don't understand the concept, but because they've just accidentally multiplied by 3 instead of multiplied by itself 3 times. All right, so just little things to be careful about. All right, so the two problems that I skipped, 5 and 11, what would be, let me get a purple pen here. For number 5, I want the product of x to the 20th and x to the 40th. So that's going to be x to the 60th. All right, keep the base at the exponents. All right, number 11, x to the 2nd to the 40th would be x to the 80th. All right.